Alright, so we've already talked about our Q equals MC delta T for when you're on a slope. So let's discuss the flat line options. Now notice we have flat or slope, but we have two more formula options. And they differ because of the area you're working with. So if we are dealing with the heat of fusion, delta H of F, fusion is melting or freezing. So this formula is going to be happening only when you're on the lower point. So whether the freezing point is 0 degrees, if it's going to be different for every substance, but if you're on the melting or freezing lines, then you would use delta H of F. And the formula is still M is mass, still. Q is still heat. But the delta H of F would be a given constant. So for water, it's 334 joules for every gram. Now, comparatively, when you look up and go to this higher level, the condensing or evaporation, that is referred to as the heat of vaporization. So for water, heat of vaporization is 2,260 joules for every 1 gram. That is a huge energy difference, but think about the types of bonds we're breaking. When we go from the fusion, melting, when we go from solid to liquid, we're breaking some of those intermolecular forces, but not all, because water molecules still like each other. That's how we have surface tension. But when you look at vaporization, it takes a lot more energy because we are breaking every single intermolecular bond. Because remember, a characteristic of gases is they are not attracted to each other. So you have to be careful because some problems require you to use at least 2 formulas. So let's look at an example of that. So if you had a question like this on your worksheet, which you will very soon, it says, suppose you sweat out 2.5 pounds of water at football practice. If all of this water evaporated, how much energy did the water absorb from your body? Now, you have to realize that, number one, the water coming out of your body is not 100 degrees Celsius. If it was, you'd be dead. Body temperature on the Celsius scale is 37 degrees Celsius. So we have to have this for a reference point, and we're going to need to start by doing our heat curve since we are evaporating. So when you label body temperature, well, that's going to be between, so this not so flat line, this is 0 degrees C. This one would be 100 because sweat is mostly water, so we'll reference water. So 37 degrees is still down here, and it's a liquid down here. But in order for it to get to where it's fully evaporated, we would say it's way over here. Well, if I chunk, I have 2 sections. I have this section of energy, and then I have this section. Once I chunk it, I see, hey, I have 2 parts that I need to do math for. I have an A part and a B part. And I have to do both parts separately to accurately calculate the amount of energy. So if I'm doing the Q from just part A, since it's a slope, I'll need to use the MC delta T. And make sure that I use the C of a liquid. For the B part, I'm going to have to use a different formula. Well, the B is on a flat, so I will have to use that M delta H. And since it's on the vaporization flat, I'll have to use the delta H of V. But before I can do any of that, notice in the question, I'm not giving a mass. I'm giving pounds of water. I don't know pounds to grams, but you can look up the conversion and find out that there are 2.2 pounds that equal 1 kilogram. Well, kilograms aren't the same as grams, Miss Abel. I know some of you are thinking that, but I can change kilograms to grams. So we use our dimensional analysis skills. So if we're starting with 2.5 pounds, excuse me, well, to change that, there's going to be 2.2 pounds for every 1 kilogram. My pounds are gone. I don't want pounds, I want grams. But I know that for every 1 kilogram, there's 1,000 grams. My kilograms are gone, and then I'll be in grams. Then, I take out my handy-dandy calculator, And all I do is 2.5 divide by 2.2, enter, that's this part, and then times by 1,000. And that gives us a mass of 1,136 grams. We'll keep it to the whole number to keep it simple. 4 sig figs is extra. So when I do the first part, well, I have my mass now. The C for liquid water, I can look that up on my notes, and that was 4.18 joules for every gram degree C. And then our change in temperature was 37 degrees to, this point, remember, is 100. So to get my change in temperature, I just do 100, which was the final for that section, minus 37. And that tells us that our change was 63 degrees. Degrees C cross out, grams cross out, and now we are multiplying, and we will know that Q of A is 1,136 multiplied by 4.18 multiplied by 63. So that brings us to 299,154 joules. Yes, I know that's huge. We'll go ahead and change that to kilojoules, and that would be 299.154 kilojoules. Now for the B part, our mass is still the same. It's still the same amount of sweat, so 1,136 grams. And we're just going to multiply that by the heat of vaporization, which was our, let me rewrite this where we have more room. So our QB will equal our mass times the delta heat of fusion, which we said was 2,260 joules grams. Remember, your grams divide out, and you just multiply. And that comes out for your QB of a whole lot. Change that to kilojoules, and you know what? It's still a whole lot. Now, when we go back to the question asked us for how much energy did the water absorb from your body. So that's a total question. So in my calculator, well, I did have the totals, but we have 299.154 from A. We could add that to our B amount. And that comes out for a Q total 2,867, go ahead and round to the whole number, kilojoules. Now, your questions can ask you to solve for any variable within our formulas. And please remember that delta T is T final minus T initial. Some of your questions may ask you to solve for T final, so look for some extra help videos on that in the near future. Have a good evening.